Okay, now let's look at example 4. Okay, here we have an RC circuit shown in the figure above. RC meaning that resistor capacitor. Okay, it's a circuit that consists of resistor and capacitor. The battery has fully charged the capacitor. Okay, so initially capacitor is already fully charged. Okay, it's already fully charged. And then at time equal to 0 second, a switch S is thrown from a position A to B. So at 0 second, maksudnya awal-awal lagi lah. Okay, right from the start dia sudah pindahkan switch S ni daripada position A ke B. So sekarang ni dia pergi position B. Okay, the battery voltage is 12 volt and the capacitance C is 3 microfarad. The current is observed to decrease to 0.4 of its initial value in 60 microsecond. Okay, so dalam situasi ni apa yang berlaku adalah the capacitor is already fully charged. Okay, awal-awal lagi dia sudah fully charged. And then apa yang berlaku bila switch tersebut is being thrown from position A to B. So dia sudah connect pergi B. Okay, mula-mula dia dekat A kan. Masa dia dekat A, apa yang berlaku ni dia tengah charge lah. So dia charge sampailah capacitor fully charge. So selepas dia charge, dia pergi position B. Maksudnya dia sudah disconnect daripada battery. Sekarang ni dia sudahlah battery. So maksudnya ini saja kita punya circuit. So bila dia disconnect daripada battery, ini bermaksud okay, what happened in this case is it's being discharged. Okay, so proses dia adalah discharge process. Okay, lagipun dia ada bagi tahu di sini the current observed to decrease, right? So current decrease bermaksud the process is a charging process, discharging process, and then dia bagi value T. Okay, first question, determine the value R. Okay, kita mau kira lah berapa resistance yang dia gunakan di sini. So in order to find value R, okay, kita keluarkan formula Q equal to Q naught E negative T over RC. Sebab value R tu ada dekat sini sahajalah. Okay, so ini adalah discharge, right? Let's double check whether this is the formula for discharge or not. Okay, so kita tengok formula for discharge. Okay, a discharging process here. Okay, this is the formula. So ngam lah. Okay, formula kita adalah this one. Okay, so we want to find the value for R here, right? This is our M. And then C dia ada bagi, this one. Okay, 3 micro. Time also given, this one. Okay, masa yang dia guna ni adalah merujuk kepada masa yang diambil untuk current tersebut, okay, decrease from 0 to 0.45 from its initial value. So kita tahu initial value. Okay, we don't know the exact value, but we know initial value of current is always 100% lah. Macam kita tengah charge kan, it's fully charged, so it's 100%. So final value dia sudah berkurang sebanyak 0.45 of its initial value. Okay, 0.45 of its initial value. Maksudnya 0.45 darab dengan initial kita adalah 100. Okay, 100%. So this one dia bagi adalah in terms of current. Since kita formula adalah charge, so current and charge they are directly proportional. Okay, according to this formula, Q is equal to IT. So kalau kalau current decrease, Q pun akan decrease with the same rate. So meaning that this one kita juga boleh tulis dia sebagai Q equal to 0.45 Q naught. Okay, since kita punya formula ini, we don't have the formula in terms of I. Okay, dalam syllabus kita punya formula adalah in terms of charge. So since Q ni adalah 0.45 Q naught, so masukkan di sini. And then Q naught is just Q naught. Okay, we don't know the exact value, but we know it's 100%. Okay, T is 60 micro. And and then divided by R is what we want to find. C, capacitance is 3 micro. And then as you can see here, Q naught ni walaupun kita tidak tahu, but since they are on the same, they are on both sides, we can cancel out. And then kamu tekanlah calculator. Okay, so here it will be R equal to 25 ohm. Okay, so that's the first one. Second one, we want to find time constant tau. Okay, time constant and time is not the same. Time constant dan value T yang ini dia bukan benda yang sama, because time constant is equivalent to RC. So we already have the value for resistance just now. Just masukkan capacitance 3 micro. So you will get time constant equal to 7.5 exponent -5 second. Okay, next one, the value of charge Q on the capacitor at 0 second. At 0 ni maksudnya initial lah. Okay, the initial value for Q naught. So we want to find initial, this one. Okay, if we are using this formula again, okay, kita mau kira Q naught. Q kita boleh kira sebab kita tahu Q adalah 0.4 Q naught. Okay, so boleh masukkan guna formula ni, or we can also using another formula di mana kita relate dengan capacitance and voltage. Okay, the formula from the first subtopic, Q is equal to CV. Since kita mau cari initial, so maksudnya dekat sini akan jadi Q naught. Okay, dekat sini pun akan jadi V naught. Okay, so remember, during the charging and discharging process, voltage dia akan berubah. Okay, that's why it's important for us to label V naught, sebab kita perlukan V naught yang asal, V naught yang initial. Okay, so what is the V naught initial? V naught initial is when it is fully charged, right? So bila dia fully charged, okay, dia punya voltage akan jadi yang paling maksimum. Okay, which is based on the battery. So battery dia adalah 12 volt. Itulah maximum voltage dia, which is also the initial voltage. So let's use this one because this one is easier. So C is 3 exponent -6, and then voltage is 12 volt. So you will get 3.6 exponent -5 coulomb. Okay, so if you want to use this formula also can. Cuma ni formula dia banyak benda kita kena substitute. Kamu akan dapat jawapan yang sama juga. Okay, it's the same value. Okay, last one, question D. Okay, question D, we want to find the remaining charge in the capacitor at 100 microsecond. So the remaining charge maksudnya final charge. Okay, final charge at T 100 microsecond. So kalau dia bagi value T ni, memang inilah formula yang kita perlu gunakan. Okay, Q final is what we want to find. Q naught, Q initial kita sudah ada. So T dekat sini ubahlah kepada T yang dia bagi, 100 microsecond. And then you masukkan Q naught sudah dapat tadi, 3.6 exponent -5. E naught negative T is -100 micro, and then divided by RC. So RC ni sama dengan time constant kan, so masukkan yang itu sajalah. Then you tekan calculator, so you will get Q final equal to 9.49 exponent -6 coulomb.